All right, hello everybody. This is Mr. Burley back here again. Today we're going to talk about graphing. So I'm going to go over today how to make a position time graph, how to make a velocity time graph, and how to make an acceleration time graph, and the interesting things that we'll be able to get from those. So the first one is going to be a position time graph. The first thing listed in physics is always going to be your y-axis. So on this, our y-axis is going to be the position, the x-axis is going to be the time. The slope of this, which would be position over time, is going to be either velocity, if we're talking about displacement over time, or speed, if we're talking about distance over time. If this is not a straight line, that would mean your velocity or your speed would be changing, and that would mean that you have acceleration. This could be constant, or it could be changing acceleration. From the curved line, you would not be able to tell. All right, so an example. A runner travels 50 meters in 10 seconds. Then he speeds up to travel 75 meters in the next 10 seconds. He rests for 10 seconds. He then turns around and jogs back to his starting position in 30 seconds. What would the position time graph look like? So the first thing that I'm going to do is, make sure my smartboard is zeroed up. So everything looks clear, but I can I'm going to make a chart of XY values. And so I'm going to start at 0, 0. Remember that it's position versus time. So this is going to be my position. This is going to be my time. And now I'm going to set up ordered pairs that I'm going to plot. So my first time is 10 seconds. When it's 10 seconds, he's at 50 meters. Then he speeds up to travel 75 meters in the next 10 seconds. So that means that he went from 10 seconds to 20 seconds. So my next point is going to be 20. And he went from 50 and he added 75. So now he's located at 120. He's going to rest for 10 seconds. So my time's going to go from 20 to 30 seconds, where my distance is going to stay the same. Then he's going to turn around and go back to his starting position in 30 more seconds. So that means he'll be at 60 seconds at that point, and he started at 0. And so you can see that this is our displacement each way. So we have our initial displacement was 50, then for the second part it was 75, then it was 0, and then for the last part it would be negative 125. On this side, these are our time increments. The first part took 10 seconds, the next part took 10 seconds, then another 10 seconds, and then 30 seconds. All right, so we're going to set this up on a position time graph. All right, so my first point is going to be 0, 0. At time 0 seconds, I'm at position 0. Then at 10 seconds, I end up at 50. So I'm going to put a point there. So this is going to be 10, 50. Then they went 75. So I'm going to have 20, 125. Then he stays still for 10 seconds, so I'm going to have 30, 125. Then it's going to go back down to the initial position, which is going to be 60, 0. So this is what my graph is going to look like. I can connect these, and each one of these increments is going to represent one of the segments, and we'll see how I get to, that should be a straight line. All right, so my total distance. My total distance will just be how far he travels. So he went 50, plus 75 plus 0 plus 125. So this is going to give me 250 meters. Displacement would be my final position minus my initial position. He finally ends up at 0, and he started at 0. So the displacement would be 0 meters. I'm going to find the speed for each of the segments. So to find the speed, I'm going to find the slope. And this is going to be the total distance over time. So looking at what we have for our first segment, remember our slope formula is y2 minus y1 over x2 minus x1. So I'm going to have 50 minus 0 meters over 10 minus 0 seconds. So my first increment is going to be 5 meters per second. My second one's going to go from 10 comma 50 to 20 comma 125. So using the same thing again, I'm going to have 125 minus 50 meters, and this is again going to take 10 seconds, but now I'm ending up at 20 seconds and starting at 10 seconds. So this is going to be 75 divided by 10, or 7.5 meters per second. The third segment is going to go from 20 seconds to 30 seconds, but the y doesn't change. So I'm going to have 125 minus 125 over 30 minus 20. And so this segment here is 0 meters per second. And then the final one is going to go from 30 comma 125 to 60 comma 0. So this is going to be 0 minus 125 divided by 60 minus 30. Now, if you put this in a calculator, you're going to get negative 4.16. But speeds can't be negative. So for each segment, I'm going to have 5, 7.5, 0, and 4.2. All right, average speed is a little bit different. Average speed is going to be the total distance over the total time. So in this total thing, it says it goes 250 meters. And this 250 meters is going to take it 60 seconds. So my average speed is going to be 250 over 60, which is going to be 4 1/6 meters per second. My average velocity is going to be my displacement over time, and this is going to be 0 meters over 60 seconds, so it's going to be 0 meters per second. So whereas I have an average speed of 4 1/6, my average velocity is 0. All right, I'm going to pause this because it's not letting me change colors, and I'll come back.